Hi everyone. In this video, I am going to teach you how to plot the point or how to precisely locate the position of the point when the polar coordinates are given. Let's take an example. The polar coordinate, the general format of writing the polar coordinates of any point is r, theta. This is the general format of writing the polar coordinates for a point. Here this is given here 2 comma 120 degree. Let's plot this point which is given in the polar coordinate. This is the polar coordinate format. Polar coordinate. Let's plot this point on the xy plane. Let's make a xy plane. This is positive. This is x-axis positive, and this is y-axis, and the intersections of the x-axis and the y-axis is taken as the origin. Now let's plot this point which is given in polar coordinate on the xy plane. Without changing, here I am going to plot this point directly, that means without changing it into the Cartesian coordinate. I already made the separate video on how to change the polar coordinate to the Cartesian coordinate, but here I am going to plot this point without changing into the Cartesian coordinate. Here is the radius is 2. Let's make an circle of the radius 2 unit. This is 1 unit, this is 2 unit. Now making a circle of the radius 2 unit. We need the radius of the circle 2 unit, so I made a circle of the radius 2 unit. This is the circle of the radius 2 unit. And here the another parameters of this polar coordinate, this is the argument is here given as a 120 degrees. So making an angle of 120 degree with the positive x-axis. This is the positive x-axis. Now making an angle of 120 degree with this axis. Now make, this is 90 degree. Let's take in 120 degree lies here. This is the line segment which make 120 degree with the positive x-axis. This angle in counterclockwise direction is 120 degree. And this is the, let's say this is the O and this is A. Here a line segment OA is constructed which is inclined 120 degree with positive x-axis. Now the second step is finding the intersections of this line segment OA and the circle. Here the intersection point of the line segment and the circle is this point. So this point represents 2 120 degree. Here we find out the locations of the point when the polar coordinate is given. This is the locations. This point is the locations of this point. The point is given in the polar coordinate format. We precisely calculate the locations of this point on the xy plane. This is the required locations, and this format of the writing is polar representation. This is polar representation. Here we represent a point in polar form. Let's take another examples related to the graph of the polar coordinate. Let's take another example, and the example is here -2, 120 degree. Here in these questions only the radial part is changed. Here the here 2, here is -2, and this is the case. This is the case when the radial distance, this radial distance is given negative, and the process of locating this point is first of all making the positive radial distance. Let's take the 2 comma 120 degree. Here the negative 2 is given, we take positive 2. This is the first step. In first step, if the negative radial distance is given, then we neglect the negative sign and we just only take the positive value. Here the negative 2 is given, so we take positive 2 and 120 degree. This is the positive. Now plotting this point. Now plotting this point on the xy plane. The plotting method is same as before. Now plotting 2 comma 120 degree. Here let's suppose this is 1 unit and this is 2 unit. Let's make a circle of the 2 unit radius. Here we construct our circle of the radius 2 unit. This is the circle of the radius 2 unit. Now the second step is moving to the argument section. Here the argument is 120 degree, making an angle of 120 degree with positive x-axis. This is the positive x-axis. Now making an angle of 120 degree. Here we make 120 degree with positive x-axis in counterclockwise direction. This is 120 degree. The line segment is, let's say this is y. The line segment is y. And now finding the intersections of the line segment and the circle. And this point is the intersection point of the line segment and the circle, and this point represents the point 2 comma 120 degree. But we need here negative 2 comma 120 degree, and the method is just flipping this vector. Here a vector from origin towards the point A. Here this vector, this line segment, this is a vector from the origin. This is a vector. Now flipping the position of this vector, or doing the opposite directions. Here this vector goes this direction. Now taking the opposite directions of this vector, and this is the opposite directions of that vector. Here we just take the opposite directions in opposite directions. And here we got a point. Let's make the point here. Here we got a point, and this point is this point, negative 2 comma 120 degree. Here we let's summarize this process. Here we first neglect the negative sign of the radial vector. Just we take the positive 2 comma 120 degree, and then we plot this point 2 comma 120 degree on the xy plane. We already discussed about the plotting methods. Here we already plot the 2 comma 120 degree, and here also. And then after plotting the point 2 comma 120 degree, we flip this radial distance. We flip this radial vector, and then our line is constructed. Our line segment is constructed in the opposite directions of these vectors, and the intersections of this line and the circle is the required point. This is the required point, and this point can be written, it has the equivalent, and this equivalent is equivalent to this polar coordinate is equivalent to, for this point we can write it is the 2 comma, it is below the x-axis, below the positive x-axis. Now finding this angle, the angle is in clockwise directions. Now finding this angle, here this is 90 degree, this is 120 degree, 120 degree, whole 120 degree. This is 90 degree, this is 30 degree, and this is 30 degree, but it is the whole is 90 degree, so this is 30 degree. Here we calculate this is 30 degree, but we need this angle. This is total is 90 degrees, so this is 60 degree. So writing method is negative 60 degree because it is in clockwise direction, so negative sign. So this polar coordinate is equivalent this polar coordinate. This is the polar equivalent of this point. Now we can make another equivalent, another polar equivalent. Now either this point can be written, this is the 2 comma, because it is the length of the 2 unit, 2 comma, and it is located now in counterclockwise directions from the positive x-axis. This angle, this total angle, now calculating this total angle, now calculating this total angle from the positive axis. This is here, from here to here, this is 120 degree, plus this is the straight line 180 degree. This is 120 degree plus 180 degree. 180 degree plus 120 degree gives 300 degree. Here we measure the angle of this line segment. This line, let's say this is A prime. Angle between the line segment OA prime with positive x-axis. Here this red line shows the angle with the line segment OA prime and the positive x-axis in counterclockwise direction, and here we got the angle of 300 degree. It is positive because it is in counterclockwise direction, anti-clockwise direction. These points, these 3 points are the polar equivalent of the original point. These are the polar equivalent. These two are polar equivalent. These two are the polar equivalents. So for a point, we can use the different polar equivalents. We can use the many polar equivalents for the same point. Here we use two polar equivalents. In this way, we plot the two type of the questions here on the polar representations. In one questions, the radial distance is given positive, and in next question, the radial distance is given negative. And in negative case, we first select the positive one, and then first plot the positive values, and then do the opposite directions of the radial vector. In the negative case, we have to flip the radial vector. So we flip the radial vector this way in opposite directions. So we got the final point, which is the our required point. And for this point, we can use the different polar equivalents. Here we write the polar equivalents for this point also. In this way, we can plot the position, or we can locate the position of the point precisely by using the concept of the polar coordinates. Here we don't change the polar coordinate into the Cartesian coordinate. We directly plot the positions of the point by looking the polar coordinate. Please remember these methods for plotting the point when the polar coordinates are given. In our next video, we will discuss more about the polar and the Cartesian coordinate systems. Please keep watching this channel. That's all for today. Thank you.